Okay, back with another example of implicit differentiation. We've got x cubed plus 4xy minus y squared is equal to 7. Our goal, as always, find dy dx. We have our steps right here once again. You're looking at this problem right now and wondering, what are we going to do about that? Okay, we'll talk about that in 1 second, but that is the big purpose of this, showing you this problem right here. So here we go. We have x cubed, derivative of x cubed, 3x squared. Good. All right, 3x squared goes down. Plus. Now we see we have 4x times y. 4xy or 4x times y. We said the word times, which means we have a product. If we have a product and we're deriving, we need to use the product rule. Exactly. Okay, so we have to do a product rule here. I'm going to use the red marker for a second. We're basically going to split this up into two parts. The part that includes the y and the part that does not. So we've got the 4x, that's part number 1, and then the y is part number 2. Okay? So product rule says derive each part individually and keep the other part untouched as when you're deriving the first part. So here we go. Derivative of the first part, derivative of 4x, that's going to be 4. Okay? Now we keep the y. Okay? So we did the derivative of the first times the second. Okay. Plus. All right? Now we alternate. Now we keep the 4x and we derive y. Well, derivative of y, x, if we just go with x derives to 1. So y will derive to 1 as well. But because it's a y term and we're deriving a y term, we need dy dx. So technically, there is a 1 right here. That's the derivative of y, and then dy dx right after it. Okay, you don't have to write the 1 though. Okay. Over on the other side, oops, not yet. I'm jumping ahead of myself, sorry about that. Then we have minus y squared. Derivative of y squared, we've done this a couple times now, that will be 2y dy dx. Again, we are deriving a y term, so we need the dy dx. Okay, so you may be thinking right now, I'm going to do a quick timeout from this problem. Why is there no dy dx right here? Okay, and the reason being is that because we took the derivative of 4x, which is 4, and then we just moved the y right down. We did not derive the y, and since we did not derive the y, we don't put in a dy dx. Okay, but here, all right, we did derive the y to 1. And because we took the derivative of y, we need the dy dx. Same thing, y squared had a derivative of 2y. It was the derivative of a y term, so we need the dy dx there as well. So these two terms get a dy dx because we derived a y term. This one does not because we did not derive a y term. Okay, now we can do the other side. Derivative of 7 is 0. Good. Okay, let's get dy dx all by itself. That's our goal. Isolate dy dx. Okay, well, that means just like the previous example, get the non-dy dx terms out of there. So the 3x squared and the 4y, they are over to the other side. All right, our algebra skills tell us, that we can do this by subtraction. So we'll subtract 3x squared and 4y from both sides. Okay, so that gives us 4x dy dx minus 2y dy dx is equal to negative 3x squared minus 4y. Okay, just like last time, two dy dx terms, we're going to factor the dy dx out. We're going to isolate it out. Dy dx factored out. What's left over? Well, 4x is left over from the first term, and minus 2y is left over from the second term. Okay, we didn't do anything over on the other side, so we still have minus 3x squared minus 4y. Okay. Now we're almost done. We need dy dx to be all by itself, so we're going to do some division. Division will eliminate everything on the left side except for the dy dx. Okay, but it means we also have to do that same quotient over on the other side. We got to divide by 4x minus 2y. So we're left with dy dx on the left, and we have negative 3x squared minus 4y over 4x minus 2y left on the right. That is our derivative. It's defined by both x and y. That's great. No big deal. Okay. Hopefully this worked out well for you. We're going to do one more involving chain rule momentarily.